So in today's video, we want to look at integration by substitution. So the idea is to look at the integrand of a particular integral and try to find the derivative, some expression that's given by the derivative of another expression in the integrand. So let's have a look at this first example. So we want to integrate x times e to the x squared. So what we can do to make things much simpler is we'll let u equal x squared, and then we notice that du on dx is equal to 2x. So in particular, if we flip this, then dx on du is 1 over 2x, and so in particular dx is du on 2x. Okay, so now if we look at this expression here, what we get is the integral of x now times e to the u, because u is x squared, and now dx is du on 2x. Now the x's will cancel, and so what we end up with is 1/2 integral of e to the u du, but that's just 1/2 e to the u plus some constant. And now what we do is substitute back. So we'll have 1/2 e to the x squared plus some constant. And that's it. Okay, let's look at a slightly more complicated one. So here we have the integral of 2x minus 5 over the square root of x squared minus 5x plus 6. So what we'll do here is we'll let u equal x squared minus 5x plus 6. So then du on dx is 2x minus 5. So dx is 1 over 2x minus 5 du. So then our given expression becomes 2x minus 5 divided by the square root of u, because of our choice, times du over 2x minus 5. But that's now just the integral of 1 over the square root of u du. Just to simplify things, we can write this as u to the minus 1/2. And then here, if we have n is equal to minus 1/2, we use the rule x to the n plus 1 over n plus 1. So this becomes u to the 1/2 over 1/2 plus a constant, but that's just 2 square root of u plus a constant. And now we just substitute back. So we'll get 2 times the square root of x squared minus 5x plus 6 plus a constant. Okay, let's do one more example. So here we have the integral of e to the 2x minus e to the minus 2x over e to the 2x plus e to the minus 2x. So what I'm going to do here is set u equal to e to the 2x minus e to the minus 2x. Now du on dx is 2e to the 2x plus 2e to the minus 2x dx. We've got a dx in the denominator. So now dx is equal to 1 over 2 e to the 2x plus e to the minus 2x, and then we'll have a du. So now this expression becomes u, e to the 2x plus e to the minus 2x times du. Now notice that this is not quite what we want, so what we'll do is we'll actually make a different substitution. So what we'll do instead is we'll choose it to be a plus. So originally I was choosing it to be the numerator, but it would actually be much better to do it as the denominator. So in particular now, if we go back, so let's just rub this out. What we'll find now is that we get 2e to the 2x minus 2e to the minus 2x. Now dx on du is 1 over 2 e to the 2x minus e to the minus 2x. And this is much better. So dx is now du over here. So let's just do that. And so now our expression will be e to the 2x minus e to the minus 2x over e to the 2x plus e to the minus 2x times du 2 times e to the 2x minus e to the minus 2x. But now this is just 1/2 integral 1 over u du, which is 1/2 of the natural log of u plus a constant. But that's just 1/2 times the natural log of e to the 2x plus e to the minus 2x plus a constant. So you probably in general should look at the denominator term and try to find the derivative of the denominator into the inside the numerator, because of the way that this multiplication works. Okay, so that's it for this video. If you like the video, please hit the like button and consider subscribing if you're new to the channel. There'll be notes to accompany this video in the video description, and if you have any questions, please leave them down in the comment section down below.